Okay, now we get to the next section of our trigonometry progression, and it's the sine law. We have a sine law and the cosine law. We'll worry about the sine law right now, and I think that should take us up to the point where I get back from BC, hopefully. The sine law states that any triangle, whether it's a right angle triangle or not, can be solved by finding the sine of an angle, and let's see if we can get this pen working. If I take the sine of an angle, any angle here, and I divide it by its opposite side, it'll be equal to the same value of the sine of a different angle compared to its opposite side. And it doesn't matter what kind of triangle you draw, this always works. So the sine of C over divided by C is going to be the same as, it's going to give you the exact same number as the sine of B over side B, which is going to be the exact same ratio as the angle C, or the sine of the angle C, divided by its opposite side. So what we're in essence doing is, with the sine law, is we're looking for what we're hunting for opposite partners. Okay? Now there's one little thing we have to do before we go too far is how to label a triangle. Triangles are labeled in two ways. One with capital letters, which we use to signify angles, and then lowercase letters, or baby letters, to indicate the length of a side. So here, side C is marked with a lowercase letter, and side B is indicated with a lowercase letter, and side A is also indicated with a lowercase letter. Now the only thing is, the sides are always partnered up with their opposite angles. So if this is angle A, the opposite side automatically becomes side A. If this is angle C, its opposite side automatically becomes side C, and following the pattern, if this is angle B, then its opposite side is labeled as side B. So that's how we distinguish what side is what, and when you get word problems and you're going to draw the triangles, which becomes a must, that is one thing you have to remember. So if you forget that, just come back to this portion of the video and take a look at this picture right here. All right, moving on to the next slide. Here's the sine law, and again, there's the picture that was on the previous page, and here is the formula. So there's the formula used, and it's the easiest formula to use in all of math, because you simply find an angle, take the length of its opposite side, and that's all there is to it. And what this is saying is that those opposite partners, angle A and A, gives me the exact same number as angle B and its opposite side of B, and angle C and its opposite side of C. So what I say is you need to find opposite partners. And the opposite partners in this case are the angle and its opposite side. So we're hunting. So I'll show you an example. This is really easy to do, and hopefully you can pick it up. So if I've got a triangle here, and I know that this angle is 16 degrees, and this angle here is 9 degrees, and I'm looking for side X, which is labeled here in green, well, it's not a right angle triangle, so I have to use SOHCAHTOA. Now the problem here, and I've left this as a bit of a tricky one, is that you need to find opposite partners. So I know one set of opposite partners right there. Oopsies, back that train up. Right here. So here's an angle, and its opposite side right there, I have one set of opposite partners. I need a second set of opposite partners. And so what I'm looking for now is what matches up with the side X, because that's the side I'm looking for. So there's side X. Its opposite partner would be this angle, which I don't know. And the first reaction is to say, well, I can't do it because I don't know what that angle is. And you need two sets of opposite partners. I can't say, can't use this one because I don't know that length. And that's its opposite partner. So what I have to do is I have to figure out what this angle is. And you're going to say, well, it's not given to you. But you can find it out easy enough because we do know something about triangles. We know they add up to 180 degrees. And we know we're subtracting 9 and 16 from that. And so that gives me an angle of 155 degrees. So this angle here is actually 155. So now that I've got two opposite partners, I've got this opposite partner here, and I've got that angle on that side there, I can set up the ratio. And so the formula states that sine A over A equals sine B over B. Now it doesn't matter which one's A or B or C because this triangle is not labeled. So what I just know is that this angle here, sine of 9 over its opposite partner, 8.2, is going to give me the exact same answer as the sine of 155 over x. And so what I'm looking for turns out to be that right there. That's what I'm hunting for. So I used my opposite angles and sides, 9 and 8.2 and 155 at x, to solve for x. So there's my ratio. So once I get to here, and I say this all the time, I said this to you in trigonometry before, finding the equation, finding that step right there, that's the hardest piece, easily. If you can get that set up properly, the rest is just simply algebra. All right, so we're going to back this up a little bit, and I'm going to create some space so I can do some work here. So there's my ratio, and my ratio is right here. And it's the sine 9 over 8.2 equals sine of 155 over x. So I'm going to cross multiply, or I'm going to get rid of the fractions. And so I can do this a number of ways, Zorro not being one of them, thank you very much, Mr. Smith. And I'm going to take a look, and I'm going to cross multiply. So I would get, I'm just going to do my work up here so I've got some room. Sine x times sine of 9, x times, where'd my pen go? Here we go. X times sine of 9, 8.2. No, what am I doing? What am I to slow this down? Let's back this up again. Cross multiply here. So I get x times sine of 9. Oh, I am struggling right now. Sorry, kids. Here we go. X times the sine of 9 equals, and I'm going to cross multiply that, and I'm going to get 8.2 sine of 155. All right? So I have that. I divide both sides by sine of 9 to isolate the variable. Sine of 9. So then x equals 8.2 times the sine of 155 over sine of 9. So when I pop that into my calculator, I get an answer of 22.2. Now if that's meters, centimeters, it wasn't indicated in the question, but there's the answer. Now the first thing I have to do is obviously check, is that reasonable? And it's reasonable because 155 is my biggest side, which means x has to be my longest length. And since it's longer than 8.2, I have to assume that I've done the work right. So there's the sine law. The key is to find opposite partners, set up your ratio like this. And you could cross multiply or multiply both sides by a common denominator to get rid of the fraction. And then once I've got rid of the fraction, I isolate, I divide that out, so I isolate my variable. Okay? And then again, just look to see what's reasonable. All right, so here's a question from your work text, and this is found on page 472. So this is on page 472. Okay. So what I have here is I have a question that's got this triangle set up. And so I've got an angle of 75. I've got an angle of 39, and I know this length here of 8.1. Well, I have to set up a sine ratio. They're asking me to find the length of QR. Q to R is this length right here. So I have to figure out what's opposite of that. Well, that is opposite of that. So I'm going to set up sine of 75 over P equals, and the only other opposite partner I have here is this one and this one. Well, I don't know that angle, but I do know that it's going to be sine of whatever this angle is. Well, I'm just going to take 180, subtract 75, subtract 39, and that gives me, what's that, 114, 180 subtract 114 would be 76. Nope, 66. So sine of 66. All right. So once I set that up, that's the hard part right there. That's the gold ticket. If you get that set up properly, now we're just going to cross multiply, and I'm going to get 8.1 sine of 75 equals, so there's that multiplication, and this multiplication gives me equals P times the sine of 66. Now I want to isolate P, so I'm going to divide both sides by sine of, what happened there? Oh, nice. I'm going to multiply both sides by, or divide both sides by sine of 66. So I divide this by sine of 66. That divides out, so I divide this by sine, oh, let's make that better, sine of 66. Wow. Just looking for some help here, machine. Thank you. That's why I lock it, dumbass. Okay, here we go. Sine of 66. All right, so once I have that, I have P over here, and then I pop this into my calculator. So if you've got a graphing calculator or display calculator, what you want to make sure is that you put that in brackets. If you've got a calculator that doesn't display the work, you're going to want to go 75 sine, get that answer, multiply that by 8.1, and then take the answer and divide it by sine of 66. In any case, you should get an answer of 8.6. All right? And then again, you look at the value of that, and you see if that's reasonable. And if you look at that diagram, where'd the diagram go? My goodness. Wow. And, well, you can check it on page 472 and see it, because I don't know what's going on. I'm not